Hello, guys. So this is our a different session, very important session where we are going to solve a very hard problem, which is based on trees, dynamic programming, and maths, all three at the same time. And it was asked in Uber OI recently. Okay, this is weekend. People are enjoying their lives at this time, and here I am shooting video solution to such hard DSE problems for my students. I have decided to make this video public to YouTube community as well because I think it will be helpful to many students because I have seen that tree DP and rerouting DP being asked many times in online assessments of top companies, good companies, normal companies, whatever. So I think we should solve this problem. So guys, this is the link to the problem. Now the link to the problem, okay, link to the problem, then solution to the problem, everything with the code will be mentioned in the description. Okay, and if you guys are interested in my mentoring program where I teach a DSA of interview level and OA level and give dev training for each day for 8 months, so guys, if you guys are interested, you can check it out. Many of my students are currently working at good companies as they got successful. So if you also want to be successful, you can surely join my program. All the details will be in the description below, okay, in the YouTube description. And also make sure to like and subscribe so you guys can get these important online assessment videos and learn as much as possible, because I see that in the market everyone is just teaching interview level DSA and not teaching online assessment level DSA. Okay, the things, the kind of DSA, the patterns, the topics, etc. asked in online assessment for DSA are very very different, so you need to have some different kind of practice for it. Okay, so let's start. So, guys, the problem states that we are given a tree with n nodes. Okay, this problem assumes that you have the knowledge of tree, BFS, and DFS. Okay, and I will mention the links to the resources if you want to study in case you don't know. So we are given a tree with n nodes and n minus one edges. The tree is rooted at one. Very good. Okay, the nodes are labeled from one to n. We have to find the number of vertices such that there exists exactly one vertex which is a prime number on the path between vertex I and vertex j. Pairs I comma j and j comma I are considered the same. So we are given this tree, we are given any random general tree. What we have to do is, guys, just assume that this is the tree given to us. Okay, just assume that this is the tree given to us. Okay, this is the tree. They are saying find the number of paths such that find the number of good paths. They are saying find the number of good paths. Okay, now let me say what is the meaning of a good path. Good path is nothing but a path which has exactly one prime number in it, one prime number, exactly one prime number. That's it. Okay. So I think I should open up a Google document as well because it might be needed. Okay, let me open this one only. Let's see. Yeah. So let's go below. Let's increase the size to 50 at least. So guys, the size we are using is 55. So for now, what is the meaning of good path? Okay, good path is the path which has exactly one prime number. Okay, this thing is clear, exactly one prime number. Okay, very good. So guys, in the given tree, how can we find the number of paths which are good? Okay, so for example, in this tree there is one path which I can see which is good. It is 1 comma 2. This path is a good path. Why? Because it has exactly one prime number which is 2. Then there is one more good path which is 3 to 4. Why is this a good path? This is a good path because 3 is a prime number. Now 3 to 5 is not a good path. Why it is not a good path in the tree? It is not a good path because both are prime numbers. We only want one prime number. Now guys, these things can get very very complicated. For example, the path can be as long as possible. Okay, say we have a tree like this. Okay, very very complicated general tree. Okay, any number of children, any number of subtrees, whatever. Okay, large trees, as we saw that n is less than equal to 10 raised to 5. So the good path can start from here and it can be like this also. Got it? This full can be a good path. Okay, so you guys need to calculate all such good paths. Okay, you need to calculate all such good paths. This thing will involve, the solution will involve a dynamic programming on trees. Okay, it will involve DP on tree and some basic maths, or you can say prime number maths, which we can say sieve of Eratosthenes. Okay, Eratosthenes. Okay, this is basically used to just find out if a number is prime or not. Okay, so we will use this as a black box. Okay, black box means you don't need to understand how this works, you just need to know that this works. Okay, and this gives you the output. This tells you if a given number is prime or not. Okay, to reduce the complexity, we will assume that we have this feature. We can know in just know o of one time. Okay, just assume that in o of one time we can find out if the number is prime or not. So forget this complexity for now, that how will we know if the number is prime or not. For example, just assume that we know which number is prime and which number is not prime. So how will we find those number of paths is a very big question. Okay, so guys, I want to explain before going to the actual question. Let's assume you have this middle node. Okay, you have this node of the tree. Okay, now guys, just assume this is prime. Okay, this is prime. What does this mean? This means that all the paths coming from this node will be the good paths, because they will only be having one prime number. So say there are so many paths here. Okay, infinite. We are not just not like we are not taking into account how many paths and how many stuff is there, but there is lots of stuff on the left side, and just assume there is lots of stuff on the right side as well. Okay, so guys, just assume there are x nodes. Okay, or let's assume there are b nodes on the left hand side of the our main prime number node, and there are let's say y nodes on the right hand side. Okay, b nodes on the left hand sides and y nodes on the right hand side. Okay, so what will be the number of paths which involve exactly one prime number? It will be b into y. As easy as that. So this concept we need to clear up. How did it happen? So guys, p means a number which is prime, and z means a number which is not prime. So say you have p is in the middle. Okay, and you have so many subtrees like this. Say z, 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 z. This is also z, 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 z. Okay, this is the left hand side. Now on the right also you have say z, say some more z. The number of nodes here is 2. The number of nodes here 1, 2, 3, 4, 5, 6, 7, 7. So guys, the answer will be 7 into 2, 14. There are 14 paths. One will start from this z, it will end here. One from this z, this will end here. Like this for every other z from left to right. That's why I'm multiplying the number of nodes. Got it? So the number of paths is directly dependent on the number of nodes. So guys, I hope that this thing is clear. Okay. Why was I explaining this trick? Let me explain, because I know that some of my big you viewers will be very very beginners, so I'm explaining this trick in the start only. Say that we have a very nice good tree like this. Okay, yeah, it can be anything. Okay, it can be anything like this. Say that we have a big tree like this, and 5 is our, just assume, okay, it is a prime number, but just assume that this is a prime number. Okay, now if you know the number of nodes above 5 which are good, say these nodes are z1, or let's say they are b good nodes are there, b good nodes are there above 5. And if you know that how many good nodes are below 5, say there are y good nodes below 5, then guys the answer is very very simple. If you know this b and y, the number of paths is always b into y. Now what is the meaning of those good nodes? Good nodes mean the nodes which are not prime. Okay, for example, say this is my p number node. Okay, this is a prime number. Then z means not prime. This is also not prime. This is also not prime. This is also not prime. Now say a p comes here. Okay, and then there is a z. Then p also has three z's. Okay, okay, it has three z's. Yeah, okay, three sets. Now let's only focus, there are two types of nodes guys. Okay, the nodes at the down and the nodes at the up nodes. These are the up nodes and these are the down nodes. Only let's just focus on the down nodes for now. Let's just forget how to calculate the up nodes for now. So we have this down node. Okay, so guys, if I ask you for this point prime number p, all the paths which will be coming from this prime number, how many they see up nodes, just assume it is y and good nodes is b. So what is the number b here? A person can say, okay, 1 2 3 4 5 6 7 8 9, b equal to 9. but this is wrong. B is not 9. You only have to go till the place you are continuously finding Z. So you find Z, okay, good. You find Z, good. One, 2, 3, 4. Okay. So 4 nodes are good nodes. This Z is also good, 5. But as soon as you find a P, now you forget this full subtree. Don't count further. Just forget it. Why? Because if the path starts from P and it again reaches P, then it will have two prime number. Two prime number is not allowed. That's why. So whenever you find a subtree whose root node is prime number, you have to ignore that. So just stop iterating. Stop going down below. Got it? So here the good nodes are 1, 2, 3, 4, 5. So B is 5. So guys, our task is divided into some more tasks. Okay. We have to find number of good nodes. In that have to find number of good nodes which are down, or we can say which are in down phase. Then you have to find number of good nodes which are in up phase. Okay, up phase. So guys, how will we calculate the number of down nodes? Okay, I will tell you how. We will be doing a DFS on the tree, and we will be iterating it in the pre-order, or we can say post-order fashion. Okay, where we will be iterating the bottommost node first, then we will iterate the uppermost nodes. So we will store the up. See, down of I will mean the number of good nodes for node I. Okay, number of good nodes for node I. Okay, number of good nodes for node I. Number of good nodes for node I in down phase, but that is common sense. यहाँ पर down लिखा तो down की बात कर रहा रहूंगा. Okay, so guys, how will I calculate the number of good nodes? Okay, let's just say I have this tree. Okay, I have this tree. Okay, okay. So I can calculate, I have a down array. Okay, this will be down of 1, 2, 3. Okay, this is 1, this is 2, this is 3. Let's just give any number: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So guys, what I will be doing now is, first I will calculate the down value of the bottommost node. This is easy to calculate. So dp of 8, then dp of 9, all these values will be 0 because there are no nodes below them. Okay, dp of 10, or let's, okay, dp is nothing but down. Okay, you can call it down or dp, both are the same thing. So down of 8, down of 9, down of 10, let me write it as dp for now. Dp of, then all the numbers like dp of 11, 12, 13, 14, 15, all this is 0. All this is 0. Okay, now say if I want to calculate the dp of 6. So 6 is looking like this. This is 6, here there is 12, here there is 13. You can check it in the previous diagram. Okay, you can check it in the previous diagram here. Okay, so how will you calculate it? How many good nodes are there? So is this 6 a prime number? No, but okay, this is Z, this is Z, but this P, this is a prime number. Okay, we only have to count the nodes which are continuously in Z way, not in the P way. So what I will do, I just need to know the number of good down nodes for this subtree and this subtree. Then I need to add 1 because I have to include this node as well. So dp of 6 will be nothing but dp of 12 plus 1, then plus dp of 13 plus 1. These two things I have to add. I have to add the value of down dp of all the childs plus 1. Why? To include this node as well. Okay, so guys, dp of 12 plus 1 you can include, very good, because this is not a prime number. Okay, but dp of 13 plus 1 you cannot include in your answer. Why? You cannot include it because this is a prime number. So you have to stop, you have to ignore this, because you can never take it, because you want the paths which don't have any kind of prime number in them. Okay, got it? So we don't have to touch the p values in the down direction. That's why we stop there. So in general, what would be our dp value for node I? This is my node I, okay, and say this is my child 1, child 2, okay, then these childs are big, huh? They have large trees in their bottoms. Child 1, child 2, then I have child 3, then I have child 4, then I have child 5, okay. So guys, the answer will be nothing but dp of I is nothing but dp of c1 plus 1 plus dp of c2 plus 1 plus similarly for other dpc 3 4 5, but you will remove the terms which are prime. So for example, say c2 is a prime number, c1 is z, this is also z, this is also z, and every, and say c5 is prime number. So we will only add dp c1 plus 1, then dp c3 plus 1, c4 plus 1, c2 and c5 plus 1 you will ignore because these are prime numbers, so ignore those subtrees. So I hope guys till this till here everything is clear, okay. So guys, now I want to explain that how will we calculate the up nodes. Up nodes we calculate up of I. The number of nodes which are good in the upwards direction. Okay. These are the number of nodes good in the upward direction. So we'll calculate it by rerouting DP. Okay, in the rerouting DP style. Okay. Let's reroute. Let's end this layoff and recession. So say I have say this. Okay. Now I will try to traverse the things in the BFS order from the topmost node, not from the downmost. Okay, from the topmost I will try to iterate. So guys, what is up of 1? Up of 1 is 0 because there are no nodes above. So up of 1 is 0. Okay. Now let's just assume that this was 1 and this is 2 and we have so many nodes below. Okay, like so many nodes below, so many subtrees below. Okay, full tree can be imagined like this. So guys, up of 2 will be what? Nothing but up of 1. Like whatever good nodes were there for you, I just add them up for ourselves. So up of 2 is nothing but up of 1 plus 1. Why? Because up of 1 does not include 1, so you have to add this also, up of 1 plus 1. As simple as that. Okay, now let us make things more complicated. Say I have a node x here, okay, and I have so many subtrees here. Subtree 1, subtree 2, okay, then I have its parent node, okay, let's say it is y, and then there are more nodes. One node in a tree will only have one parent, okay, that's the special, that's why the tree is special definition of tree. Now this y node must also be having, bro, guys and bros and sisters, uh, and girls, sorry. So this girls, so this y node will also be having some child na. This was one, x was one child, one, let's make a z1 as a child, let's make z2 as the child, and so on. So guys, what will be the upper value of x? How many nodes above x are good nodes? Okay, simple thing, if y is not a prime number, if it is something like z, not a prime number, then you will just up of x is nothing but what, whatever good nodes were there above y, up of y plus 1, because we want to include y as well, up of y plus 1 plus. So when you do up of y plus 1 means this much nodes you have counted. Now this z1 and z2 are remaining because z1 and z2 are kind of above x, that's why we have to count them as well. Okay, so the good thing is z1 you can always calculate and z2 you can always calculate, because z1 the answer for z1 is nothing but what, down of z1 plus 1 to include z1 as well, and z2 is nothing but what, down of z2 plus 1. Okay, so these things are a bit complicated, but you need to understand the things which are going down for this node are actually up for this node, that's why. So this is included, and when you add down z1 plus 1 and down z2 plus 1, these both also get included. Okay, now you know what guys, what was the easier trick? The easier trick is to write up of y plus 1 plus down of y, down of y. Down of y means all these all gets included, down of x with down of z1 with down of z2. Because x is coming again, so we subtract that and write down of y minus down of x. Okay, now this you only have to do if x is not a prime number and y is also not a prime number. If these are prime number, when we then we will just ignore the y completely, because there is no sense in going up if the this number is only prime. Okay, and if this guy is prime, then we will not subtract down of x. Why will we not subtract down of x? Because down, okay, if this, okay, we will not subtract down of x on down of y, because down of y already would not have counted down of x because x was prime, right? So try to imagine in that manner, then the things will be easier for you. Okay, so these things were very very important. Now guys, before I go ahead, let me say how will we calculate our final answer. Let's say this is the node. Okay, this is the node. Very nice, very interesting. Now, guys, the thing is that you have a subtree, and this is a prime number. Okay, for each node, how will I calculate the answer? I'm just trying to explain that. This is a prime number. Okay, there are some, say, some nodes. Okay, there are, say, two nodes. Okay, three, five nodes. Okay, and then there are huge subtrees below. Subtree is nothing but a tree, guys. Like array has sub array, tree has subtree. Simple. All these are huge going down below. Just imagining. Okay, and this p has a father, his parent, which is z. Like the father, there will be many ancestors, but let's just imagine this as this. So guys, what will be the answer for this? We need to calculate. Okay, so the final answer for the pth node, so let's say answer of p. Answer of P is nothing but what? Up of P. You know, I taught in the beginning, multiply all the up nodes with the below nodes. Up of P multiplied with down of P. This is the first term. Okay. All the nodes below trying to come make pairs with good nodes above P. Okay. So up of P into down of P. So this thing is very much clear. Now, also, you should do this thing, what we say, you should add two numbers, which is down of p plus up of p plus up of p. Why? I will explain. Because let's say, this was my node, and above there were some mm, these were the good nodes. This is prime, this is z, this is z, this is z, this is z, and here this is z, this is z. What you did here, it is 2 good, 2 1 2 3 4 4. You said that the answer is 4 into 2 8. Okay, you compared, you made all the pairs, but you forgot the pairs which were just starting with p. p to z ये वाला तो तुमने गिना ही नहीं. सिर्फ जो p से स्टार्ट हो रहा है वो तो गिना ही नहीं, मतलब pairs वाले बना ले, बट जो p से pair बन रहे हैं उनका क्या? So this you did not count, 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 then ये you did not count, this also did not count. So answer was 4 into 2 plus 4 plus 2 plus ये चार भी इंक्लूड करो और ये दो भी अलग से इंक्लूड करो जो p से बन रहे हैं सब पैर. भूलना नहीं है इनको. So up of p into down of p plus डाउन ऑफ पी प्लस अप ऑफ पी. अब इसके अलावा भी और है चीजें. ठीक है. नाउ गाइस, दैट अप द थिंग्स इन द अपर डायरेक्शन आर नॉट कॉम्प्लिकेटेड. ओके, things in the upward direction are easy, because for any node there is only one parent up, but when we go down we have multiple branches. So say you have C1 good nodes here, C2 good nodes here, C3 good nodes here, C4 good nodes here, C5 good nodes here. But you never considered the fact, what if the path starts from some C1 node and it comes to C2, or the path starts from C3, it reaches the prime number P and it comes to C5. So how will we calculate these combinations? Okay, how will we calculate these combinations? So what we can do is, answer is nothing but C1 into the summation of rest of the nodes, because all the nodes of C1 can bond them with C2, C3, C4, C5. So C1 into C2 plus C3 plus C4 plus C5, plus when you come to C2 you can bond with 3, 4, 5. C2 into C3 plus C4 plus C5 plus C4, when you come to C4 you can bond with C5. Okay, I'm not again considering the that C4 can bond with C1, C2, C3, because you already considered that when you are going from left to right. So don't count again and again. Okay. Like full. So C4 into C5, and when you come to C5 there is nothing to compare. So C5 into 0. So guys, the full answer is what? Full answer of P is nothing but up of P into down of P plus down of p plus up of p plus, see how complicated and nice this question is, c1 into c2 plus c3 plus c4 plus c5, c2 into c3, this, okay. C1 is nothing but the number of good nodes of subtree c1. So c1 is nothing but down of C1 plus 1. But we are considering that C1 is a not a prime number. If it was a prime, now I would just ignore. If C1 was a prime, I would ignore and I would just focus on the rest of the nodes which are non-prime. Okay. So C1, C5, all I have considered as non-prime. In case any node is prime, you just ignore it. Only take the group of nodes which are prime, because if something is prime, how can you make the paths from there? Only one P is already there. Okay. So guys, this is the solution. Now let me explain the code. Yeah, so guys, what is happening in the code? First, I have this sieve of Eratosthenes. Okay, I run it till value n. This means that I am already storing in my arrays if all the numbers from 1 to n, which numbers are prime and which number are not prime. So if I write if pr of I equal to true, it means it is prime, or else it is not prime. Okay, the language in this question doesn't matter, but yeah, the problem is really hard. Okay, so guys, the thing is first I take the tree, I accept the tree, then I do the DFS down. Okay, I try to calculate the number of down nodes for each node. So guys, this is very simple. I just did a DFS to, I have a special trick. I don't have a special trick, this is just a normal thing. To start in, I wanted to do it from post order. I wanted to travel the nodes which are in the bottommost level first while doing DFS down to calculate down nodes, good nodes which are in the down phase. So what I do is at the final, when the DFS is mostly done, like just after writing the DFS condition, I what I do is for the down node I iterate all the nodes and I add the down nodes which are not prime. See, if PR of u is not prime, then just add that number and that is equal to down of node. Okay, so that's how I calculate down nodes. Then I calculate up nodes. So guys, for up nodes, you can see that I am doing a breadth first search here. Okay, BFS. I'm traveling from first node, then I'm going to second node, third node, fifth node, sixth node. So that's how I'm calculating the up nodes. Then how I'm calculating the final answer, I'm iterating through all the nodes 1 to n. Only if the current node is prime. Okay, so I want to calculate all the number of paths which are coming out of this prime number. So what I do is down of I into up of I, just like I taught you guys. Okay, and also I add down of I plus up of I. See, plus up of I have done here, and down of I automatically happens in this step only. Then I also do that c1 into that whatever addition I was doing. I make a vector of all the good nodes which are in the children subtree. Okay, I store them in that my vector is v vector. Okay, vector v. Then for the vector v, I do the same trick which I was saying here. Okay, c1 c2 c3 c4 5 in my vector. How will I calculate? I will take the value of the first value, then I will keep a running sum of whatever this I have. When I come to C2, I will subtract from this sum C2 and I will multiply C2 into this remaining sum. So like this I will get the answer. I will send that in return and then I will add all those values. Okay, just for a last time, let me explain what is up of I and down of I. So whenever you are at this node, say this is a prime number and we have things like this for us. Okay, say this is Z, 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 this is P, this is Z, this is Z, this is P, Z, this is P. So all you want below these nodes are the good nodes which don't have prime number in them. You don't even want the subtrees which have a prime number in them. So you consider this one, this one, this one, this one, this one. As soon as you find a P, you ignore it. As soon as you find a P, ignore everything below P. You ignore, take this one, ignore this one. So you, for each node, you know all the good stuff below, all the good stuff up, then you multiply up into down. Okay, up into down. So only doing up into down is not is not enough. Why? Because the good nodes can also get down, good nodes can have multiple connections with each other. Okay, like this. The up you don't have to worry because only one parent is there for each tree, so you can ignore that one. But for this c1 nodes can make pairs with C2. A path can start from here, reach P, and then reach C2. Path can start from C1, reach C3, then C4, the C5. That's why I multiply C1 into C2 plus C3, C4, C5, then C2 into C3 plus C4 plus C5, plus C3 into C4 plus C5, plus C4 into C5, plus C5 into 0. Okay, that's the signal. Okay. So C5 into 0, C5 into 0. So I hope guys the thing is clear. I have uploaded everything. So make sure you guys go through everything. And yeah, that's it for the video. I'm now stopping the recording.